Welcome you guys to pressure and volume. We are still working on learning target 3. So we are going to learn today about how pressure and volume interact with one another. So let's do a little bit of review about solids, liquids, and gases. So do you remember how those molecules and atoms are arranged? If you do, go ahead and start writing in those boxes what you think. So we're talking specifically about those particles found in there. So the first one is solids. How do those particles move and behave in solids? Hopefully you said that solids are tightly packed together and they vibrate in motion. So take a minute to go ahead and draw a picture of those particles found in a solid in the box. Liquids, a little bit different than solids. What do those molecules do? You should have said something to the extent of liquid molecules are farther apart and they can move past each other. Make sure you include a drawing with color about what liquid molecules look like. And finally, gases. How do those molecules move? Gases are typically very far apart. They collide with one another very randomly. So make sure you draw those particles spread far out. And here's an example of what some of those particles would look like. Right here in the solid, they're really tightly packed with one another. But in the liquid, you can see they're still moving, but there's some space in between them, and gases are pretty far apart. So if we were to dive a little bit deeper about those phases of matter, a little more information that you can add to your chart. Solids hold their shape and have that fixed volume because those particles are close together. Liquids always take the shape of a container. They have a free surface and they have a fixed volume due to their particles. And gases always take the shape and the volume of the container because those gases like to move around. So if we talk about movement, looking below your chart, you've got the terms kinetic molecular theory. And with those arrows, we can break it down. What does the term kinetic mean? In physical science, you should have learned that kinetic means movement. So be sure to add movement underneath the arrow for kinetic. Molecular or molecules. What are molecules? Molecules are very small. So the term molecular means small. And then the last one, a theory. Oftentimes we think of a theory as a guess, but a theory in science is a little bit different. A theory in science means that it is a reliable account of the real world, meaning scientists have done lots of experiments to back up their theory behind why something does something or why it behaves that way. So kinetic molecular theory, or KMT, means we have a movement of small molecules. So we can make a prediction of how these small molecules behave. And there's 4 parts to the kinetic molecular theory, and we'll break them down. The first part is gas particles are very small compared to the distance separating them. So those gas particles, we can't see them. Very, very tiny, and they move around. Number 2, gas molecules are in constant random motion. They collide with one another, and they collide with the walls of the container. We learned about this concept when we learned about pressure. That collision causes our gas pressure. Third part of the kinetic molecular theory talks about those collisions. And those collisions are elastic. And what that means is that they're like little rubber balls and they bounce off of one another. But unlike a rubber ball, which will eventually lose its energy, gas molecules don't lose any of their kinetic energy. They just keep on moving and moving and moving. So that's why we say that those collisions are elastic. the last part of the kinetic molecular theory, talks about temperature. So when the temperature increases, what happens to those speed? It increases. So the average kinetic energy is going to increase as the temperature increases. So next we'll show you guys a little video on the kinetic molecular theory.
The kinetic molecular theory is the theory that all matter is made up of atoms and molecules that are always moving. These particles hold kinetic energy and move around in random directions. In higher temperatures, the particles have high energy, and in low temperatures, the particles have less energy. The more energy a particle has, the faster it will move. In solids such as ice, the particles hardly move at all and hold a regular pattern because the energy is low and the particles are tightly packed. In liquids such as water, the particles have more energy and the freedom to move around. Liquids have the ability to flow and fill the shape of any container they are put in. In gases like steam, the particles have the most energy. These particles are sparse and move around freely. Gases are usually invisible to the eye and they can be expanded and compressed in different pressures. All matter is composed of atoms and molecules that are always moving. The higher the temperature, the more energy these particles have. And that is the kinetic molecular theory.
So we've learned about the particles and how they're arranged. We've learned about the kinetic molecular theory and the 4 parts to it and how those particles are going to behave. Now we're going to learn about the relationship between pressure and volume. And what that relationship is called Boyle's law. So the first part of Boyle's law is that gases can be compressed. We know that gases can be compressed because they have a lot of space in between them. So if we were to compress that gas, we would say that the volume decreases. So if we are decreasing that volume, it means that those little gas particles don't have a lot of space to move around in, so they're going to collide with one another and the sides of the containers, increasing the pressure. So the inversely is true. So if we increase the volume or make it bigger, there's more room for those molecules to move around in, and so the pressure is decreased. And why? Pressure is a result of those collisions with the sides of the container. And if the container becomes smaller, the molecules collide with the sides of the container, which results in increased pressure. So here's a nice little visual representation. You do have this on your note sheet. What you are missing on your note sheet, though, is you do not have these particles inside of this container. So what I'd like you to do is take out some colors and draw in the particles colliding with themselves and colliding with the sides of the container. So as a review, our volume right here increases, so there's more space. And so those collisions are going to occur a little less frequently, so the pressure will decrease. When we squeeze the container down and decrease the volume, the pressure in the gas will increase. So a little fun visual representation is looking at these peeps if we're talking about pressure and volume relationship.